Today we are going to talk about this paper called Video Inference for Human Body Pose and Shape Estimation. It was published in 2020. Before we get started, here is the statement. This presentation only covers part of the paper. If you find it useful, please refer to the original paper for details. Thanks. This paper's goal is to address the challenge that previous method could not capture the complex variability of human motion due to the lack of training data. To tackle this issue, it proposed an adversarial learning framework. Using an existing large-scale motion capture dataset, AMASS, and it's an unpaired training approach. We can see the figure here that there are two parts. The left part consists of a regression network that outputs temporal pose and shapes parameters, and the right part is a discriminator that discriminates between real human motions and the mesh sequence that the left part outputs. During training, first, we will input an image sequence into the CNN pre-trained for single image body pose and shape estimation, and follow by a GRU temporal encoder and a regressor, which output SMPLO parameters for each image frame. Then a motion discriminator is to take predicted pose along with real pose sampled from the AMASS dataset. The whole model is supervised by adversarial loss and regression loss. The regression loss is to minimize the key points error, pose, and shape parameters error. The data flow will be like list for each frame in a sequence. We'll go through the CNN and output a feature with dimension 2048, and these features will be encoded by GRU and output SMPLO parameters. SMPLO is a 3D mesh representation. It consists of pose and shape parameters, pose and shape. And with these 82 parameters, the SMPLO molecule output a 3D mesh. I will put the SMPLO's paper link in the description. If you are interested in more detail, you could check it out. It's worth noticing that the output feature would be like this. Where PT stands for pose parameters at each time, and for the shape parameters, we will apply average pooling to obtain only one parameters and feed it into the discriminator. As for the architecture of the discriminator, it consists of GRU layers followed by a self-attention layer, and the final outputs would be a real fake probability for each sequence. The Vive uses Spin's human mesh recovery network as feature extractor to perform the experiments. Spin is the previous state-of-the-art model. Based on the experimental result, the proposed method achieved better performance, and it can be attributed to motion discriminator and the self-attention mechanism. Motion discriminator not only is able to produce smoother motion, but also improve the single frame mesh. Compared to the static pulling method, self-attention is able to learn a better representation of the motion sequence by weighting features from each individual frame. Okay, thank you guys for listening to this presentation. Let's see you in the next paper introduction.